Have you ever noticed that the moon always shows you the same face? Night after night, year after year, one half of an entire world remains hidden from your eyes. Not hidden by clouds or distance, but by something far more profound. A rhythm so slow, so patient, that it took humanity centuries to truly understand it. Close your eyes for a moment. Breathe. Imagine standing on a beach at midnight. The moon rises above the horizon, pale and luminous. You see its craters, its mountains, the patterns of light and shadow that have inspired poets and dreamers since the beginning of time. Tomorrow night it will rise again, the same face, the same craters, the same mountains in the same places. This is not magic. This is not a mystery hidden from science. What you are witnessing is something far more beautiful. A story written by gravity itself, unfolding across billions of years. For thousands of years, humans looked up and wondered. Why does the moon never spin? Why does it never show us its other side? Some imagined hidden worlds on the far face. Others thought it was simply the way things were meant to be, unchanging and eternal. But the moon was not always still. Billions of years ago, when it first formed from the debris of a cosmic collision, the moon spun freely. It tumbled through space. It rotated rapidly, showing different faces to the young Earth below. And then, slowly, almost imperceptibly, something changed. Gravity began its patient work. The Earth's pull grew stronger and more focused, and over vast stretches of time the moon's spin slowed, and slowed, and slowed, until eventually it stopped spinning altogether relative to Earth. This is what we call tidal locking, not a sudden event, not a dramatic moment in history, but a gentle, inexorable process that took millions of years to complete. And it is happening all around the universe right now, in ways you cannot see but can absolutely understand. Before we journey deeper into this story, I invite you to join our community. Subscribe to the Relaxing Science channel. Give this video a like, and please share in the comments below. Where are you listening from right now? What time is it where you are? Your presence here matters, and I would love to know. The moon's stillness is not a secret. It is a conversation between two worlds, written in the language of gravity and time. Tonight, we explore how motion becomes rhythm, how a spinning world can slow its dance until it moves in perfect synchronization with the one it orbits. We will understand what rotation truly means, and why the moon's behavior is not mysterious at all, but rather the most natural thing in the universe. And as we journey through this story, something remarkable will happen. You will begin to see the moon differently, not as a distant, unchanging object in the sky, but as a living example of how the universe works, how everything is connected, how time and gravity shape the cosmos in ways both gentle and profound. The moon has been your companion since you were born. It has watched over your nights. It has inspired your dreams. And yet, you may never have truly understood why it always shows you the same face. That changes now. This is a journey into deep time, into the slow, patient forces that shape worlds, into the reason why you see the same craters, the same mountains, the same patterns of light and shadow, night after night after night. There is no rush in this story. There is no urgency. Only the steady rhythm of two worlds moving together, locked in an eternal dance that began billions of years ago and will continue for billions of years to come. The moon does not spin relative to Earth anymore, but it is far from still. It is moving. It is changing. It is participating in a cosmic choreography so vast and so slow that human eyes can barely perceive it, yet you can feel it. When you look up at the moon, when you see its pale light crossing the night sky, when you feel the tides in your own body, because yes, the moon influences your body too, you are experiencing this dance. You are part of this story. Settle into a comfortable position. Let your breathing become slow and steady. There is no need to rush through this experience. We have time. The moon has taught us that time is the greatest teacher of all. In the moments ahead, we will explore the science behind lunar stillness. We will understand rotation and orbital mechanics without complexity or jargon. We will see how the moon's behavior connects to every spinning object in the universe, from distant galaxies to the particles in your own cells. But more than that, we will experience a shift in perspective. The moon will no longer be a distant, unchanging object. It will become a teacher, a reminder that the universe works through patience, through subtle forces, through the steady application of gravity across incomprehensible spans of time. You have always known that the moon never turns, but you may never have truly understood why. That understanding is about to unfold. This is not a video about facts. This is an invitation into a deeper relationship with the cosmos, a chance to see the universe not as something distant and cold, but as something intimate and alive, constantly moving, constantly changing, constantly teaching us about the nature of motion, time, and connection. The moon's locked face is not a riddle. It is a love letter from gravity itself, written across billions of years. And we are about to read it together. As we established, the moon presents the same face to Earth night after night, but understanding why requires us to step beyond the simple observation and into the nature of rotation itself. Rotation is not what most people imagine it to be. When you think of spinning, you picture something turning around its own center, a top spinning on a table, a planet twirling in space. But rotation is far more subtle than this mental image suggests. It is a relationship between an object and the space around it. It is motion measured not just by speed, but by direction, by time, and by forces acting from outside. The moon rotates. This is crucial to understand. It does not sit still in space like a frozen marble. It spins around its own axis once every 27.3 days. This is not coincidence. This rotation takes exactly the same amount of time as the moon needs to orbit Earth. One complete spin around its own center. One complete journey around our planet. The numbers match perfectly. This matching is the key to everything that follows. Most people hear this fact and assume the moon stopped rotating long ago. They imagine it was somehow locked in place, held rigid by invisible chains. This is not what happened. The moon's rotation did not cease. Instead, it slowed, gradually, steadily. Over billions of years, the moon's spin gradually matched its orbital motion. The two became synchronized. This synchronization is called tidal locking, and it is not unique to our moon. Consider Jupiter's moon Io. It orbits its giant host every 42 hours. It rotates around its own axis every 42 hours. Europa, another Jovian moon, shows the same pattern. Triton, orbiting Neptune, exhibits identical behavior. Across the solar system, wherever a smaller body orbits a much larger one for long enough, this synchronization emerges. It is not a rare occurrence, it is inevitable. The mechanism behind this lies in gravity and motion combined. When the moon orbits Earth, gravity does not pull equally on every part of the moon's body. The side facing Earth experiences stronger gravitational pull than the far side. This difference creates stress within the moon's rocky structure. It stretches the moon slightly, creating a bulge on the side facing Earth and another on the opposite side. These bulges are permanent features of the moon's shape. Now imagine the moon rotating faster than it orbits. The bulges would lag behind. They would be pulled backward by the moon's spin, like a wave on a rope being dragged by the rope's motion. This creates friction within the moon's interior. The friction generates heat. This heat dissipates energy. Over time, this energy loss slows the moon's rotation. The bulges eventually align with the gravitational pull. When they do, the friction disappears. The rotation slows no further. Equilibrium is reached. This process took immense time. The moon formed roughly 4.5 billion years ago, born from a collision between the early Earth and a Mars-sized body. In those early days, the moon orbited much closer to Earth than it does now. The gravitational forces were far stronger. The tidal bulges were more pronounced. The friction was intense. The moon's rotation slowed rapidly during this period. As the moon moved away from Earth, gravity's grip weakened. The tidal forces diminished. The rotation continued to slow, but at a decreasing rate. Eventually, after hundreds of millions of years, the rotation synchronized with the orbit. The moon settled into its current rhythm. Today, this synchronization is stable. The moon will continue showing the same face to Earth for billions of years to come. This is not stasis. This is not the moon frozen in time. This is a dynamic equilibrium. The moon still rotates. It still feels Earth's gravitational pull. The bulges still exist. but they are now perfectly aligned with the direction of Earth's gravity. Though friction occurs, no energy is lost. Motion and gravity have found a balance point, and in that balance, the moon appears motionless to us. Here lies a profound insight about rotation itself. Rotation is not an absolute property of an object. It is relative. It depends on the observer's perspective. From Earth's perspective, the moon does not rotate relative to us. From the moon's perspective, from a point in space beyond the Earth-Moon system, the moon spins steadily. Both statements are true. Both describe the same physical reality from different viewpoints. This brings us to an important distinction. The term dark side of the moon is misleading. It suggests a side that never sees light, a shadowed realm hidden forever. This is incorrect. Every part of the moon receives sunlight for roughly 2 weeks during each lunar month. The side we never see is not dark in the sense of being perpetually shadowed. It is simply the far side. It is the hemisphere we cannot observe from Earth because the moon's rotation matches its orbit. The far side of the moon is not darker than the near side. It is not colder. It is not more mysterious. It is simply the other half of a world that has settled into a stable relationship with its parent planet. Early spacecraft and satellites have photographed it extensively. It appears much like the near side, covered in craters, mountains, and plains of ancient lava. The only difference is our inability to see it from Earth's surface. Understanding rotation in this way opens a door to comprehending how celestial bodies interact over deep time. Motion is not fixed. Speed is not permanent. Given enough time and under the influence of gravity, moving bodies settle into patterns. These patterns are not imposed from outside. They emerge naturally from the laws of physics. The moon's synchronized rotation is a testament to patience. It is a reminder that change in the cosmos operates on scales we find difficult to imagine. Billions of years, gradual slowing, imperceptible adjustments, and yet the result is profound. An entire world has oriented itself toward its partner in space, and in doing so has created one of the most stable configurations in our solar system. Imagine standing on the moon's surface 4.5 billion years ago. The ground beneath your feet trembles. The world spins wildly, rotating much faster than it does today. Above you, Earth hangs enormous in the sky, not distant and serene as it appears from our world, but close, massive, and pulling with tremendous force. This is the story of how violence became stillness, how chaos settled into rhythm through the patient work of gravity over deep time. When the moon first formed, shortly after our solar system itself, it was born from catastrophe. A Mars-sized object collided with the young Earth. The impact was so violent that it melted rock, vaporized water, and sent debris spiraling into orbit. From this cosmic wreckage, the moon coalesced. It was closer then, much closer. Where it now orbits at an average distance of 238,000 miles, it once hung only about 16,000 miles away. And it spun. It spun rapidly, completing a rotation in perhaps 6 hours or less. At that distance, with Earth so near and so massive, gravitational forces worked upon the moon with relentless intensity. Imagine stretching a rubber ball while it spins. The stretching creates resistance. The spinning slows. This is what happened to the moon, except the stretching force was gravity, and the timescale was not seconds but billions of years. The moon's rocky body is not uniform. It has denser regions and lighter regions. As it orbited Earth, the gravitational pull was stronger on the side facing our planet. This created a bulge, a slight elongation toward Earth. But because the moon was spinning faster than it was orbiting, this bulge could not keep pace. It lagged behind. Imagine a spinning top with a weight attached to one side. As it spins, that weight wants to move forward, but the spin carries it backward. The result is friction, resistance, a slowing effect. This is tidal friction. It is not dramatic. It does not happen in a moment. It happens across millions of years, then billions of years. With each orbit, with each tidal bulge created and left behind by the moon's rotation, energy was dissipated. The moon's spin gradually, steadily, almost imperceptibly slowed. Meanwhile, something else occurred. The same gravitational forces that slowed the moon's rotation also affected Earth. The moon's tidal bulge pulled on Earth's oceans, creating the tides we know today. But more than that, it pulled on Earth's rotation. Our planet spins faster than the moon orbits. So the tidal bulge on Earth is dragged ahead by our planet's rotation. This dragging creates a force that pulls the moon forward in its orbit, gradually pushing it away from Earth. This is a beautiful symmetry. The moon loses rotational energy and slows its spin. Earth loses rotational energy and slows its spin. The moon gains orbital energy and moves away. All of this happens through the same mechanism, the same patient work of gravity and friction. Nothing is wasted. Energy simply transforms, redistributes, flows from one form to another across time. As the moon slowed, its rotation period gradually approached its orbital period. The bulge that had lagged behind began to align more closely with the direction toward Earth. When rotation and orbit finally matched, when the moon completed exactly one rotation per orbit, the bulge settled into perfect alignment. The lagging stopped. The friction diminished to almost nothing. The moon had achieved tidal lock. At that moment, something profound occurred. The moon's far side, which had been spinning into view and out of view as the moon rotated faster than it orbited, became permanently hidden from Earth. But this was not a sudden darkness. It was not a mystery that appeared overnight. It was the natural conclusion of a process that had been unfolding for billions of years. The same side that had always faced Earth most of the time now faced it all of the time. Today, we can observe this process still continuing, but at an almost immeasurable pace. The moon continues to move away from Earth. Our planet's rotation continues to slow. In billions of years, Earth will rotate at the same rate it orbits the moon. We will be tidally locked to the moon, just as the moon is locked to us. The day will be as long as the month. The same side of Earth will always face the moon. This is not a secret written in darkness. It is a pattern written in physics, in the language of gravity and motion. The moon's locked face is not mysterious. It is the result of forces we can measure, understand, and trace back to their origins. When you look up at the moon tonight, you are seeing the end result of 4.5 billion years of gravitational interaction, of energy transforming, of two worlds settling into a rhythm together. The far side is not hidden in shadow or secrecy. It is simply on the other side, receiving the same sunlight that illuminates the near side. It has mountains and valleys, craters and plains. It has been explored by spacecraft. It has been photographed in detail. What made it seem mysterious was not science, but the simple fact that we could not see it from Earth. Now we understand why. Now we understand that this arrangement is not an accident or a mystery, but a natural consequence of how gravity works across time. Imagine standing on the moon's surface, looking back at Earth. The planet hangs motionless in the sky above you. It does not rise. It does not set. It simply remains, suspended in the same position, night after night, year after year. This is what tidal locking feels like from the inside. We have spoken of how the moon's rotation slowed over billions of years. We have seen how gravity shaped its motion. Now we move deeper into the mechanism itself, into the patient, invisible hand that made this transformation possible. This is the science of how gravity actually works on a spinning body, and why the moon could not have resisted its own fate. Gravity is not a force that pulls equally everywhere. When the moon orbited closer to Earth than it does today, the side facing us experienced stronger gravitational pull than the far side. This difference created what scientists call a tidal force. Think of it this way. Imagine holding a rubber ball that is being pulled toward a magnet. The side closer to the magnet stretches slightly. The far side stretches away. The ball becomes elongated, bulging on both sides. The moon experienced exactly this. Earth's gravity stretched it gently, creating two bulges, one facing Earth, one facing away. But the moon was also spinning. As it rotated, these bulges tried to maintain their alignment with Earth. The bulges wanted to face our planet, while the moon's rotation wanted to carry them around. This mismatch created friction within the moon's rock and mantle. Friction is the key. It is friction that slows a spinning top. It is friction that stops a rolling ball. Within the moon, this friction took the form of heat. The moon's interior, still warm from its formation, experienced stress as tidal forces bent and stretched its body. This stress generated heat through internal deformation. The heat was small but relentless. Night after night, or rather day after day for billions of years, this gentle friction worked. Each time the moon completed a rotation, the tidal bulges resisted its spin. The bulges wanted to stay aligned with Earth. The moon's rotation wanted to continue. This opposition created a drag, a resistance, a slow braking effect. Over millions of years, this became noticeable. Over billions of years, it became decisive. The moon's spin gradually decreased. Here is where something remarkable occurred. As the moon's rotation slowed, something else was happening simultaneously. The moon was also orbiting Earth. Its orbital period, the time it took to complete one full circle around our planet, remained relatively stable. But as the rotation period stretched out, approaching the orbital period, something inevitable happened. They began to match. When the moon's rotation period finally equaled its orbital period, the bulges locked into place. The side facing Earth always faced Earth. The tidal forces no longer created resistance because there was no longer a mismatch between rotation and orbit. The bulges had nowhere to move. They were frozen in alignment. The friction ceased. The heating stopped. Equilibrium was reached. This is tidal locking in its essence. It is not a mystery or a secret. It is the natural outcome of gravity and friction working together over deep time. The moon did not choose this fate. It simply could not escape it. Any body orbiting close enough to a massive object will eventually experience this same process. Consider what this means. The moon's unchanging face is not the result of some cosmic accident or rare occurrence. It is the inevitable conclusion of physics. Given enough time, gravity will always win. The spinning body will always slow. The orbiting body will always align. This is not unique to the moon. It is universal. We can observe this principle elsewhere in our solar system. Many moons of Jupiter and Saturn are tidally locked to their parent planets. Mercury, closest to the Sun, is tidally locked to our star. Even some exoplanets orbiting distant stars show signs of tidal locking. The moon is not exceptional. It is simply following the rules that govern motion and gravity throughout the universe. But there is more to understand. The process did not happen all at once. It was not a sudden shift from spinning freely to standing still. The moon's rotation gradually decreased in speed, like a top slowly winding down. The transition took time, hundreds of millions of years, perhaps longer. During this transition, the moon's face changed relative to us. Different hemispheres rotated into view. The far side gradually came into view, and then slowly disappeared again as the lock tightened. Eventually, the rotation matched the orbit precisely. At that moment, the process stabilized. But the forces that created tidal locking did not disappear. They are still present. They are still working. The moon continues to recede from Earth at a rate of about 3 centimeters per year. As it recedes, the tidal forces weaken slightly. The lock becomes more stable, not less. The moon's fate is sealed. What about Earth? We have mentioned that Earth's rotation is also slowing due to the moon's gravity. This is the other side of the same coin. The moon pulls on Earth's oceans, creating tides. These tides experience friction as they move across the ocean floor. This friction removes energy from Earth's rotation, slowing it down. Meanwhile, the moon gains energy and moves away. It is a slow exchange, a gradual transfer, but it is happening now, in this moment, as you listen. Billions of years from now, if the moon remains in orbit around Earth, it may experience another transformation. As Earth's rotation continues to slow, it might eventually match the moon's orbital period. At that point, both bodies would be tidally locked to each other. Earth would always show the same face to the moon. The moon would always hang in the same position in Earth's sky. This is the ultimate destiny of close orbital partners, complete mutual synchronization. For now, we live in an intermediate state. The moon is locked to us, but we are still slowly turning. We see the same face of the moon every night, but the moon sees different faces of Earth as our planet spins. This will not last forever. But forever, in human terms, is incomprehensibly long. The change is so gradual that no one alive will ever notice it. This is the patience of gravity. This is the power of friction. This is how the moon came to show us only one face, not through drama or sudden change, but through the steady, inevitable application of physical law across billions of years. The moon's locked secret is no secret at all. It is simply physics, patient and eternal, written in the motion of worlds. Imagine standing in a vast hall where two dancers move together, their steps perfectly matched. One leads, one follows, yet neither seems to move at all. This is what resonance means, when two rhythms align so completely that they become one unified motion. The moon and Earth are in resonance, not by chance, but through a slow, patient conversation written in gravity and time. What we are exploring now is how that conversation maintains itself, how the moon's balance persists, and why this rhythm remains stable across billions of years. When we left off, the moon's rotation had slowed to match its orbit. The tidal bulges created by Earth's pull had done their work. But here is what makes this remarkable. The system did not simply stop. It continues to evolve, yet in a way that preserves the lock. The moon is not frozen in place. It is held in a state of dynamic equilibrium. Think of a pendulum that swings back and forth. Eventually, air resistance and friction slow it down until it hangs still. But the moon is not like a simple pendulum. It is more like a complex system where multiple forces interact continuously. Earth pulls on the moon pulls on Earth, the sun influences both. And yet, despite all these competing forces, the synchronization persists. This persistence is resonance. It is the tendency of systems to find harmony when they interact long enough. The moon's bulges point toward Earth because that is the lowest energy state. If the moon were to spin faster or slower, those bulges would be pulled out of alignment. The friction from that misalignment would then act as a brake, slowing or speeding the rotation back towards synchronization. The system self-corrects. You can feel something similar if you have ever pushed a child on a swing. Push at the right moment and the swing goes higher with less effort. Push at the wrong moment and you work against the rhythm. The swing has a natural frequency, a preferred timing. The moon has found its preferred timing with Earth. But resonance is not perfection. It is balance within limits. The moon does not point exactly at Earth at every moment. There is a small wobble, a gentle oscillation. This wobble is called libration. From Earth, it means we can see slightly more than half of the moon's surface over time, about 59%, rather than exactly 50%. The moon rocks back and forth, a tiny dance within the larger dance. This rocking happens because the moon's orbit is not a perfect circle. It is an ellipse. When the moon is closer to Earth, Earth's gravity pulls harder. When it is farther away, the pull weakens. Meanwhile, the moon's rotation remains steady, the same speed throughout its orbit. So sometimes the rotation is slightly ahead of the orbital motion, sometimes slightly behind. The moon appears to rock in our sky, revealing a little more of one edge, then a little more of the opposite edge. The libration is small, only a few degrees, but it is real and measurable. Ancient astronomers noticed it. They saw the same face always pointing toward Earth, yet they also saw that the edge of the visible region shifted slightly over weeks and months. They did not have the language of orbital mechanics to explain it, but they observed the effect. Modern instruments can measure libration to within centimeters. This subtle motion tells us something important. The moon's synchronization is not a rigid lock. It is a dynamic state. The moon is constantly being pulled, pushed and adjusted by Earth's gravity. The tidal bulges are always there, always creating friction, always exerting a torque. Yet the system remains stable because the forces are balanced in a way that preserves the synchronization. Imagine a marble rolling inside a bowl. The marble does not sit at the exact center. It settles into a position where gravity, friction, and the shape of the bowl create a stable equilibrium. The marble can roll slightly, oscillate gently, but it returns to that equilibrium position. The moon is like that marble, and the bowl is the gravitational field of Earth, combined with the moon's own inertia. This is why the moon has not suddenly started spinning faster or slower. This is why it has not flipped, to show us a different face. The resonance is self-maintaining. The system has found a state that is stable enough to persist for billions of years, yet flexible enough to allow small adjustments. The moon is also slowly moving away from Earth. Every year it recedes by about 3 centimeters. This is measurable with lasers bounced off mirrors left by astronauts. As it moves away, Earth's gravitational pull weakens slightly. You might think this would disrupt the synchronization. Instead, something remarkable happens. The resonance adjusts. The Moon's orbital period lengthens and the rotation remains locked to it. The two continue to move in harmony, even as their distance increases. This tells us that resonance is not fragile. It is robust. It adapts. As long as the forces involved change slowly relative to the time it takes for the system to respond, synchronization persists. Here is where we find ourselves in the journey. The Moon's stillness is not the absence of motion. It is the result of motion settling into rhythm. The tidal forces that once rapidly slowed the Moon's spin now maintain the synchronization in a gentle, continuous way. The bulges, the friction, the gravitational pull, these are not fighting against the lock. They are sustaining it. The Moon hangs in this state of dynamic balance, rocking slightly, receding gradually, yet always showing us the same patient face. And Earth, in turn, is slowing down. Our day grows longer by about 2 milliseconds every century. The Moon is gradually transferring its orbital energy to us, slowing our spin while moving away. In the distant future, billions of years from now, Earth and Moon may reach a new equilibrium where they are both tidally locked to each other, each always showing the same face. But that future is incomprehensibly far away. For now, in this moment, the Moon remains our steady companion, locked in a rhythm that has endured since its formation, maintained not by rigidity but by the patient, continuous work of gravity and time. Now that we understand how the Moon's rotation locked to its orbit through tidal friction, we must explore something equally fascinating: the shape of that orbit itself. The Moon does not travel in a perfect circle around Earth. Instead, it follows an ellipse, a stretched circle with two focal points, one of which holds our planet. This distinction matters deeply. A perfect circle would mean the Moon maintains constant distance from Earth at all times. But the universe does not work in perfect geometry. The Moon swings closer, then farther away, in a rhythm as old as the Moon itself. At its closest approach, called perigee, the Moon comes within 226,000 miles of Earth. At its farthest point, called apogee, it retreats to 252,000 miles away. The difference spans more than 25,000 miles. This is not a small variation. This is a meaningful oscillation in space. Why does this matter for tidal locking? Because gravity's strength depends on distance. When the Moon sits closer to Earth, our planet's gravitational pull grows stronger. When it drifts farther, that pull weakens. This changing force creates subtle variations in the tidal bulges that stretch the Moon's body. The bulges do not remain perfectly aligned. They shift slightly. They respond. Imagine holding a rubber ball and squeezing it from alternating directions. The shape changes with each squeeze. The internal friction builds. Heat develops. Over billions of years, this continuous flexing dissipates energy. The Moon loses momentum. Its orbit gradually expands. The ellipse itself evolves. This is not a static relationship. It is a conversation written in gravity and time. The Moon's elliptical orbit is not an accident or a temporary state. It is a natural consequence of how two bodies interact when one is much more massive than the other. Earth's gravity does not pull uniformly on every part of the Moon. The near side experiences stronger pull than the far side. This creates differential forces. These differential forces would cause the Moon to tumble if it were not already tidally locked. But because it is locked, because one face always points toward Earth, the tidal bulges align with the line connecting the two bodies. The system finds stability within instability. Motion persists, but it follows a pattern. The elliptical orbit also explains why libration exists. Remember that the Moon's rotation matches its orbital period. But the orbit itself moves faster when the Moon is close to Earth and slower when it is far away. This is Kepler's second law, a principle as fundamental as gravity itself. The Moon must move faster along its elliptical path when near perigee to conserve angular momentum. This speed variation means the Moon's rotation cannot perfectly match its orbital motion at every instant. Sometimes the rotation pulls slightly ahead, sometimes it falls behind. The result is that gentle rocking we call libration, It is not a flaw in the locking mechanism. It is a natural consequence of orbital mechanics. The bulges on the moon also respond to this changing distance. When the moon approaches perigee, the tidal bulges grow more pronounced. The friction intensifies. When it retreats to apogee, the bulges relax slightly. This breathing motion, repeated over millions of orbits, continuously dissipates energy from the moon's interior. Where does this energy go? It transforms into heat. The moon's interior warms from tidal friction. In fact, if you could measure the moon's internal temperature, you would find it hotter than a body of its size should be, given only the heat left from its formation. Tidal heating is real. It is measurable. It is ongoing. This heating has profound consequences. It keeps the moon's interior slightly more fluid than it would otherwise be. It may influence the moon's magnetic field, though that field is now largely dormant. It shapes the moon's geological history. Volcanic activity on the moon, which dominated its first billion years, was partly fueled by tidal heating. As the moon receded and tidal forces weakened, volcanic activity declined. The elliptical orbit also means the moon's apparent size in the sky varies. When the moon is at perigee, it appears roughly 14% larger than when at apogee. This variation is subtle to the human eye, but it is real. Ancient astronomers, watching the moon night after night, could sense this variation without instruments. They knew something was changing, even if they could not explain it. The moon's elliptical orbit is not fixed either. Over millions of years, the shape of the ellipse itself changes. The eccentricity, the degree to which the orbit deviates from a perfect circle, fluctuates due to gravitational interactions with the Sun and other bodies in the solar system. These are long-term oscillations, playing out across timescales of hundreds of thousands of years. Yet within this complexity, order emerges. The moon remains tidally locked. The tidal bulges continue to dissipate energy. The moon continues to recede. These processes are not fighting against each other. They are interconnected threads in a single tapestry of celestial mechanics. Where are you listening from, and what time is it there? I would like to know if you are settling into this journey with us, allowing these concepts to unfold at their own pace. The dance of distance between Earth and Moon is not chaotic. It is not random. It is a consequence of fundamental laws written into the fabric of physics. And it is one of the reasons the Moon's tidal locking is so stable, so enduring, so utterly reliable across billions of years. Billions of years. That span of time is almost impossible to hold in your mind. Yet it is the very measure by which the moon found its stillness. What we see tonight, that locked face, that patient gaze, is not the moon's original state. It is the moon's rested state, a state earned through patience and friction, through the slow surrender of motion itself. When the moon was young, it spun much faster. Imagine it then, a freshly formed world, still warm from its violent birth, tumbling through space with rapid rotations. Days on the early moon were shorter. Its face turned toward the Earth and then away again in what might have been hours or days. But Earth's gravity never stopped pulling. The tidal bulges we explored before were not gentle suggestions. They were relentless forces, flexing the moon's interior, generating heat through friction, dissipating energy with every rotation. This is the heart of tidal locking, energy loss. Every time the moon turned, those bulges resisted. Every resistance meant heat. Every loss of heat meant lost motion. The moon was slowly, inevitably being drained of its rotational energy. It was not a sudden collapse. It was a gradual surrender, stretching across millions of years, then tens of millions, then hundreds of millions. The timeline itself tells a story. In the moon's first billion years, the process accelerated. The moon was closer to Earth then, and closeness meant stronger gravity, stronger tidal forces, stronger resistance to rotation. The drag was intense. The moon's spin slowed noticeably across centuries and millennia, but the moon was also moving outward, very gradually, as we discussed before. This outward motion meant weaker gravity over time, which meant weaker tidal forces, which meant slower energy loss. The process that had been rapid began to settle into a gentler rhythm. By the time the moon reached its current distance from Earth, and this took billions of years, the process had nearly completed itself. The moon's rotation had already slowed to match its orbit. The energy dissipation continued, but at a much lower rate. The moon had found equilibrium, not stillness because it still moves, still orbits, still experiences tidal forces, but a kind of dynamic peace, a balance between gravity's pull and the moon's orbital motion. What makes this process so profound is that it was never controlled. No intelligence guided it, no design predetermined it. The moon simply responded to physics. Gravity pulled, friction resisted. Energy was lost, motion decreased. The system naturally evolved toward a state where the moon's rotation matched its orbit. This is not unique to the moon. Many moons throughout the solar system show the same pattern. The larger moons of Jupiter, Saturn, Neptune, nearly all of them are tidally locked to their parent planets. The physics is universal. Given enough time, gravity always wins this particular game. But there is subtlety here worth contemplating. The process did not stop. It continues even now. The moon is still receding from Earth, still losing rotational energy, still adjusting its orbit. The tidal forces still flex the moon's interior, still generating heat, still dissipating energy. The difference is that now the system is so well balanced, so perfectly synchronized, that these changes are almost imperceptible. The moon recedes about 4 centimeters per year. At that rate, it will take millions of years for any noticeable change. But the process continues, patient and inexorable. This teaches us something important about time itself. Billions of years is not an abstract number. It is a measure of how long it takes for gravity to reshape worlds. It is a measure of how patient physics can be. It is a measure of how thoroughly one object can come to know another through the simple language of force and motion. The moon's journey to stillness was also Earth's journey. As the moon slowed, Earth slowed too. Billions of years ago, Earth rotated much faster. A day on the early Earth was perhaps only 6 hours long. The same tidal forces that locked the moon to Earth were also slowing Earth's rotation. But Earth is much larger, much more massive, much more resistant to change. The process has been slower for Earth. It continues still. Each day, Earth rotates slightly slower than the day before. Each year, the day is a fraction of a second longer than the year before. In billions of years, this will matter enormously. Eventually, Earth too may become tidally locked to the moon, but that is a future so distant that it exists only in the realm of theoretical possibility. What we witness in the moon's locked face is a record of time itself. It is a fossil of motion. The moon shows us what happens when gravity has billions of years to work. It shows us that there is no escape from physics, only eventually reaching agreement with it. The moon did not choose to show us one face. It was compelled by the laws of motion and gravity, and in that compulsion there is a kind of beauty, the beauty of inevitability, the beauty of a system so perfectly balanced that it appears almost conscious, almost intentional. As you contemplate the moon tonight, you are looking at the result of 4.5 billion years of gravitational negotiation. That locked face is not a mystery or a secret. It is a conclusion. A conclusion written in the language of physics, patient and undeniable. The moon has come to rest, not because it wanted to, but because the universe itself wrote the rules, and the moon simply obeyed them, one slow rotation at a time, across the vast expanse of deep time. As the moon recedes from Earth at a pace of 3 centimeters each year, something remarkable unfolds across its surface. Light and shadow dance in ways that reveal far more than a simple division between day and night. The hemisphere we see from Earth glows under the sun's steady gaze, while the far side exists in our collective imagination as mysterious, hidden, unreachable. Yet this boundary between illumination and darkness tells a story not of secrecy, but of geometry, orbital mechanics, and the slow waltz between two worlds. When we speak of the moon's hidden side, we speak in metaphor. Nothing is truly hidden. Spacecraft have orbited the far side. Cameras have mapped every crater, every ridge, every frozen valley. What remains invisible to Earth observers is not concealed by the moon itself, but by the simple geometry of tidal locking. The same gravitational force that halted the moon's spin also determined what we see and what remains beyond our horizon. Imagine standing on the moon's equator, at the boundary between light and shadow. The sun rises slowly over the eastern horizon, takes weeks to cross the sky, and sets even more slowly in the west. A lunar day lasts nearly 30 Earth days. During this time, temperatures soar to 130 degrees Celsius in sunlit regions, then plummet to -170 degrees in darkness. This extreme swing in temperature creates stress in the rock. Thermal expansion and contraction fracture the surface, carving it into jagged terrain that speaks of this violent rhythm. The illuminated hemisphere facing Earth receives constant solar energy. This side has been mapped in extraordinary detail. We know the names of its maria, the vast dark plains formed by ancient volcanic eruptions. We recognize Tycho crater, with its brilliant rays of ejected material spreading across the surface like fingers of light. We see the mountains of the rim, the highlands that catch the sun's rays at sharp angles, creating the dramatic landscape that has inspired poets and astronomers for centuries. But the far side presents a different world entirely. Without the stabilizing influence of Earth's gravity, concentrated on one hemisphere, the far side experienced different tidal heating patterns in its distant past. The crust there is thicker, older in appearance, more heavily cratered. The absence of large maria suggests that volcanic activity there cooled and ceased earlier in lunar history. This asymmetry is not random. It is written into the moon's very structure by the relentless pull of Earth's gravity, acting preferentially on the near side. The boundary between the visible and invisible hemispheres is not a sharp line, but a gradual transition. Libration, that subtle rocking we discussed earlier, means that over time, we glimpse slightly beyond the geometric edge. 59% of the lunar surface becomes visible from Earth when you account for all the libration that accumulates across the moon's orbital cycle. The remaining 41% stays forever hidden from our vantage point. This hidden region is not dark in any meaningful sense. When the sun illuminates it, it glows as brightly as the near side. The darkness we imagine is the darkness of our perspective, the simple fact that we cannot turn around on our planetary perch to see what lies beyond. Our moon is tidally locked to us, but this is not a limitation of the moon. It is a statement about our position in space, about the geometry of orbits, and the direction from which we observe. Consider the mountains on the far side's rim. They exist in the same sunlight that illuminates the near side. They cast shadows, reflect light, weather under the assault of solar radiation and micrometeorite impacts, just as their counterparts on the visible hemisphere do. Yet we have never seen them with our own eyes. We know them only through the images returned by orbiting spacecraft and through the descriptions of those who have studied those images. The mapping of the far side transformed our understanding of the moon. It revealed that the two hemispheres are fundamentally different, not because of hidden processes, but because of the different gravitational history each experienced. The near side, pulled more strongly by Earth's gravity, heated differently, cooled differently, and evolved along a distinct path. The far side, freed from this concentrated gravitational influence, followed its own geological destiny. Light and shadow on the moon serve as a natural map of gravitational influence. Where Earth's pull was strongest, the geology tells a different story. Where that pull was weakest, the landscape speaks of older, less disturbed history. The illuminated hemisphere is not more real or more important than the hidden one. Both are equally present, equally ancient, equally shaped by the cosmic forces that govern all motion in space. As you rest with this image in your mind, picture the moon suspended in space. One face turned eternally toward us, marked by the signature of Earth's gravity. The other face turned away, equally real, equally detailed, waiting for those rare moments when human curiosity sends machines to witness what our eyes cannot. Neither side is superior. Neither is more mysterious. Both are simply different expressions of the same gravitational dance that has continued for billions of years. The journey toward understanding the moon is a journey toward accepting that mystery often dissolves when we look closely enough. What seems hidden is merely unseen. What seems secret is simply distant. The moon's far side is not kept from us by any force of nature. It is kept from us only by the simple fact that we stand on Earth, and the moon, in its patient tidal lock, keeps one face toward us always. The moon does not exist alone in space. It never has. What we witness in the night sky is not a single object frozen in place, but rather a living partnership, one that transforms both bodies involved. Earth and the Moon are locked in a slow dance of mutual influence, and this chapter reveals how that relationship reshapes our entire planetary system. Imagine standing on Earth billions of years ago. The Moon would have hung much closer to the horizon, appearing far larger than it does today. The tides would have been catastrophic. Waves would have crashed with such force that the concept of a stable shoreline would have been almost meaningless. The Moon was closer then because it has been gradually moving away. This is not a theory. Laser reflectors left by astronauts on the lunar surface allow us to measure this drift with precision. The Moon recedes from Earth at roughly 4 centimeters per year. Over geological time, this small distance compounds into something profound. But why does the Moon move away? The answer lies in the very mechanism that locked its rotation in the first place. When the Moon's tidal bulges are dragged by Earth's rotation, they create friction. This friction dissipates energy. Some of that energy comes from the Moon's orbital motion. As the Moon loses orbital energy, it must move outward to maintain its path around Earth. This is counterintuitive. Losing energy should bring objects closer, not push them away. Yet the mathematics of orbital mechanics reveals a subtle truth. As energy is removed from an orbit, the orbit actually expands. The Moon falls backward into a wider circle. This outward migration has consequences for Earth. As the Moon recedes, its gravitational grip weakens slightly. The tides which once reshaped continents gradually diminish. But there is more. The Moon's gravity also slows Earth's rotation. Every day is imperceptibly longer than the one before it. Measurements from ancient eclipse records and coral growth patterns show that a day 400 million years ago lasted only about 22 hours. The difference accumulated over time because the Moon, through its gravitational embrace, has been gradually applying the brakes to our planet's spin. This is the essence of the partnership. The Moon tidally locks itself to Earth, and in doing so, it also tidally locks Earth to itself. The influence flows both ways. Earth's rotation creates tidal bulges on the Moon. Those bulges dissipate energy. That energy loss causes the Moon to recede. As the Moon recedes, it pulls less strongly on Earth's rotation, causing our days to lengthen. It is a feedback loop written in gravity and time. Consider what this means for the future. Billions of years from now, the Moon will have moved so far away that solar eclipses will no longer occur. The Moon will appear smaller in our sky, unable to fully cover the Sun. Simultaneously, Earth's rotation will have slowed so much that a day might last 30 or 40 hours. The tides will be gentler. The night sky will look different. The Moon will remain visible, but it will seem more distant, less dominant. Life on Earth will have adapted to these gradual shifts, just as it has adapted to all the changes that have come before. Yet this future state is not the end. The Moon will continue to recede. Eventually, if the system persists long enough, the Moon might drift so far that Earth's gravity can no longer hold it. This is not imminent. It lies so far in the future that the Sun itself will have exhausted its fuel and died. But the trajectory is set. The partnership between Earth and the Moon is not eternal. It is a temporary arrangement, written in the language of physics, playing out across billions of years. The beauty of this understanding is that it connects the Moon's tidal locking to a larger story. The Moon's locked face is not a mystery or a static condition. It is a snapshot of an ongoing transformation. The Moon we see tonight is different from the Moon our ancestors saw. It will be different still for our descendants. The relationship between Earth and Moon is dynamic, patient, and governed by laws that operate everywhere in the universe. This mutual transformation reveals something profound about how celestial bodies interact. Gravity does not simply hold objects in place. It shapes them, moves them, and gradually reshapes the systems they inhabit. The Moon's tidal locking is one expression of this principle, but this same principle operates on moons orbiting Jupiter, on planets orbiting distant stars, on entire galaxies orbiting each other across incomprehensible distances. The partnership between Earth and Moon teaches us that nothing in the cosmos is truly static. Everything moves, everything changes. The timescales are vast, but they are real. A 4-centimeter drift per year seems negligible. Yet over 4 billion years, it accumulates into a transformation that has reshaped the conditions for life itself. The Moon that enabled the tides that may have nurtured the first organisms is slowly withdrawing. The moon that stabilized Earth's climate is gradually loosening its grip, and yet in this slow farewell there is no tragedy. There is only the steady, inevitable unfolding of physical law. The moon moves away because it must. Earth's rotation slows because it must. These are not choices or accidents. They are consequences, written into the very structure of gravity and motion. Where are you listening from right now? Consider the moon above you, wherever you are. It is pulling on the water beneath your feet, on the air around you, on the atoms that make up your body, and you are pulling back on it infinitesimally through your own mass. The partnership is real. It is happening now. It has been happening for 4.5 billion years, and it will continue for billions more. The moon and Earth dance together in a rhythm that extends far beyond our small corner of space. What we have learned about their relationship, the tidal locking, the gradual recession, the mutual transformation, this is not unique. It is not a peculiar story told only about our celestial pair. Look outward, and you will find this same pattern written across the universe, repeated in countless systems, each one following the same gentle laws of physics. Consider the moons of Jupiter: Io, Europa, Ganymede, Callisto, each one locked in its own gravitational embrace with the massive planet that dominates their sky. Io experiences tidal heating so intense that it reshapes the moon's interior, creating volcanoes that erupt with molten rock. Europa, smaller and colder, harbors an ocean beneath its frozen surface, kept liquid by the same tidal forces that once shaped our moon. These are not mysteries. They are echoes of the same process that has shaped Earth's moon for billions of years. The physics that governs tidal locking is universal. Wherever a smaller body orbits a larger one, wherever gravity pulls and friction dissipates energy, the outcome tends toward the same quiet resolution. The smaller body gradually loses its spin until it shows only one face to its master. This is not a rule imposed from outside. It emerges naturally from the mathematics of motion, from the patient work of gravity over immense stretches of time. Now imagine stepping further outward. Beyond our solar system, astronomers have discovered thousands of exoplanets, worlds orbiting distant stars. Many of these planets orbit so close to their stars that they are already tidally locked. One hemisphere faces eternal daylight, the other endures perpetual night. The terminator line between them, where light meets shadow, becomes a thin band where temperatures might allow liquid water to flow. Life, if it exists there, would be shaped entirely by this locked geometry. These distant worlds are not strange aberrations. They represent the future state toward which all orbiting bodies tend. Earth itself will one day become tidally locked to the Sun, though that day lies so far in the future that the Sun will have already consumed our planet. The timescales involved stretch so far beyond human comprehension that we must think of them as almost infinite. Yet the process itself is simple. It is patient. It is inevitable. What makes this pattern so profound is that it reveals something deeper about the universe itself. The laws of physics do not change from place to place. The same gravity that slows the moon's rotation operates in distant galaxies. The same friction that dissipates energy works everywhere. The universe is not random or chaotic at its foundations. It is governed by principles that are consistent, elegant, and deeply interconnected. Think of it this way. When you observe the moon in the night sky, you are not looking at an isolated phenomenon. You are witnessing a principle in action. That principle has shaped countless worlds. It continues to shape them now. It will shape worlds we have not yet discovered. The moon is a teacher, and its lesson is written in the language of physics, a language that speaks the same way everywhere. This consistency brings a kind of peace. It means that the universe is not arbitrary. The patterns we see are not accidents. They emerge from something fundamental, something that connects all motion, all gravity, all change. When you understand this, the cosmos becomes less alien. It becomes more knowable. The moon becomes not just a light in the sky, but a visible expression of laws that govern everything. Consider also the stability that tidal locking creates. Once a moon is locked, it settles into a steady state. The friction ceases. The energy dissipation slows dramatically. The system reaches an equilibrium. This is not stagnation. It is a kind of rest. The moon and Earth will continue to interact. The moon will continue to recede. Earth's rotation will continue to slow, but the rate of change will become gentler and gentler as time passes. This teaches us something about change itself. Not all change is rapid or dramatic. The most profound transformations often happen slowly, almost imperceptibly. The moon did not suddenly become locked. It took billions of years, but the result is stable. It is lasting. It has created a partnership that has endured through epochs of geological time. As we move deeper into contemplation of these cosmic patterns, we begin to see that tidal locking is not an ending, but a transition. It is a shift from one state to another, from chaos to order, from rapid change to gentle stability. The universe tends toward these stable states. It is as if the cosmos itself seeks rest, seeks balance, seeks the quiet state where energy is no longer being wasted in friction and heat. This is the poetry hidden within physics. The equations that describe tidal locking are precise and mathematical. Yet when you understand what they mean, when you grasp the billions of years of slow transformation they represent, they become something more. They become a story of patience. They become a story of how chaos settles into order. They become a story about the deep nature of time itself. The moon, in its locked orbit, reminds us that we too are part of this universal pattern. Our world is shaped by these same forces. Our lives unfold within the boundaries set by gravity and motion. We are not separate from the cosmos. We are expressions of it. We are made of the same matter that forms the moon. We are governed by the same physics that locks it in place. Everything we have learned about the moon, about tidal locking, about the slow dance between two bodies in space, all of this points to something deeper. Not just a fact to understand, but a way of seeing time itself differently. The moon teaches us that change is not always visible. For billions of years, the moon has been transforming. Its rotation has slowed. Its orbit has expanded. The tides it creates have reshaped Earth's oceans and shores. Yet from where you stand looking up on any clear night, the moon appears unchanged. The same craters, the same mountains, the same gentle face. This is the first lesson. Patience shapes the universe more than force ever could. When we think of change, we often imagine sudden events. A storm, a collision, a moment when everything shifts. But the moon's story is different. It is written in millimeters per year, in degrees of rotation, lost across millions of years. In gravitational forces so patient, they seem almost invisible until you step back and see the entire picture. Consider what this means for how you understand your own world. The ground beneath your feet is moving. Continents drift, mountains rise and fall, oceans shift their basins. Yet, in a single human lifetime, these changes feel like nothing. The Earth appears still, solid, eternal, just as the moon appears frozen in its orbit. This is the second lesson. Time operates on scales we rarely experience directly. When astronomers first discovered that the moon was tidally locked, many felt a sense of strangeness. How could an entire world stop rotating? How could it become frozen in place? The answer, we have learned, is that it did not happen suddenly. It took billions of years. The moon's early rotation was rapid. Its days were shorter than ours are now. Gradually, through the relentless pull of Earth's gravity, that rotation slowed. Eventually, it aligned perfectly with the moon's orbit. One rotation per revolution. Perfect synchronization. But here is what makes this truly remarkable. The moon is still changing. Right now, in this moment, the moon continues to recede from Earth, 4 centimeters every year. This means that someday in the distant future, so distant that the sun itself will have transformed, the moon will be far enough away that its gravity will no longer dominate Earth's tides. The tidal forces will weaken. Earth's rotation will stabilize. The partnership that has lasted billions of years will reach a new equilibrium. Neither body will be destroyed. Neither will suddenly vanish. Instead, they will settle into a new rhythm, a slower dance, a quieter relationship. This teaches us the third lesson. All relationships, even those between worlds, evolve toward new forms. Think about what this means philosophically. The moon has been humanity's constant companion since before we had language. Ancient peoples watched it. They built calendars around it. They told stories about it. They felt its pull on their emotions, their bodies, their sense of time itself. Yet all along, the moon was slowly moving away. All along, the relationship was changing. We did not notice because we live such brief lives. A human lifetime is barely a flicker against the moon's existence. We are born, we watch the moon, we die, and the moon continues unchanged from our perspective, yet fundamentally transformed across the deep time we cannot see. This is where science and contemplation meet. The moon is not a mystery to be solved and then forgotten. It is a mirror for understanding how change works in the universe, how patience creates transformation, how invisible forces shape everything we see. The moon's locked face is not a puzzle. It is a message. It says, time is longer than you imagine. Change is slower than you expect. And relationships between bodies, between worlds, between past and future, are more profound than a single moment can reveal. When you look at the moon next, you might see it differently, not as a static object hanging in the sky, but as a living record of billions of years of motion. Every crater is a moment. Every mountain is a memory. Every gentle glow is the light of a world still transforming, still moving, still dancing with Earth in a rhythm so slow that only deep time can measure it. The moon teaches us that the universe is not made of sudden events and dramatic changes. It is made of patience, of gravity working quietly across eons, of two bodies finding their way toward harmony, not through force, but through the inevitable mathematics of motion and mass. This is what the moon's locked secret truly reveals. Nothing is truly locked. Everything is flowing. Everything is changing. Some changes are simply so vast, so patient, so ancient, that they become invisible to us. They become what we call stillness, what we call eternity, what we call home. The moon has been teaching this lesson for 4.5 billion years. It will continue teaching it long after we are gone. And in that patient, endless teaching, there is a kind of peace. Imagine standing on a beach at midnight. The moon hangs above you, steady and familiar. You have seen this same face your entire life. Your parents saw it, their parents before them. Generations stretching back into time all gazed upon this identical surface. And yet, beneath this constancy lies a story of profound transformation. We have journeyed together through the moon's quiet history. We began by asking a simple question. Why does the moon never turn? That question led us through gravity's patient work, through tidal friction's slow sculpting, through the dance between two bodies locked in an embrace that reshapes them both across billions of years. The moon was not always as it is now. In its earliest days, it spun rapidly. It tumbled through space with wild energy, rotating freely like a dancer with no partner. But Earth's gravity was always there, gently insisting. Tidal forces began their work immediately, pulling on the moon's body, creating friction in its interior, draining away its rotational energy. This process was not violent, it was not sudden. It was the universe's way of saying, settle down, find rhythm, become synchronized with your partner. And the moon listened, in the language that only gravity understands. Over time, the moon's spin slowed. Faster and faster days passed until one remarkable moment arrived. The moon's rotation matched its orbit. One side faced Earth permanently. The other side turned away forever. But this was not a prison. It was a solution. It was harmony. We learned that this is not unique to our moon. Across the universe, wherever one body orbits another, this same story repeats. Jupiter's moons, Saturn's rings, distant exoplanets circling stars we will never visit. All of them follow identical laws. All of them eventually become tidally locked, showing one face to their parent bodies, locked in synchronized motion. This reveals something profound about the universe. It is not chaotic. It is not random. It follows patterns. It seeks balance. Gravity does not force objects into submission. Instead, it invites them toward equilibrium, toward stable configurations that require less energy, less struggle. And there is something beautiful in that. The universe, in its vast indifference, nevertheless guides all things toward peace. We also discovered that the moon is not static. Even now, locked as it is, it continues to change. Every year, it drifts farther from Earth. 4 centimeters, a distance you could measure with your hand. But across millions of years, this becomes significant. The moon is slowly leaving us, and as it leaves, Earth changes too. Our planet's rotation slows, days grow longer. The future will bring nights that stretch across different durations than the nights we know now. Billions of years from now, Earth and Moon will reach a new equilibrium. They will orbit in a different rhythm, but they will still be together. This is the nature of relationships in the universe. Nothing stays exactly as it is. Everything evolves. Everything moves toward new arrangements. But movement toward stability is not loss. It is transformation. It is the universe's patient way of creating new forms of harmony. The moon teaches us this lesson every night. It shows us that constancy and change are not opposites. They are partners like Earth and Moon themselves. The moon appears constant to us because we live such brief lives. We see only a single chapter in a story that spans billions of years. But if we step back, if we imagine time on the scale the universe actually operates, we see constant motion, constant evolution, constant patient transformation. There is no dark side of the moon. There is only a far side, a hidden side, a side we cannot see from Earth. But it is not mysterious in the way we once thought. It is simply the other half of a world, rotating in perfect synchronization with its orbit, following laws as precise and beautiful as any symphony. The moon's locked face is not a secret the universe keeps from us. It is an answer the universe gives to the question of how two bodies can move together across infinity. It is gravity's patient solution. It is time's gentle work. It is the universe saying, this is how things settle. This is how motion becomes rhythm. This is how chaos becomes order. And perhaps that is the deepest lesson of all. We live in a universe that moves toward harmony, not through force, but through patience. Not through sudden changes, but through slow, steady, imperceptible transformations that, across deep time, reshape everything. You can feel this truth right now. Your own body is part of this universe. Your own movements follow these same laws. Your heartbeat is a rhythm created by your body's need for synchronization. Your breathing follows patterns that your body has learned across evolution. Even your thoughts move in waves, in cycles, in patterns that seek their own equilibrium. The moon is not separate from you, it is a mirror. It shows you how the universe operates. It shows you that change and constancy are the same thing, viewed across different scales of time. Thank you for joining me on this journey into the moon's quiet story. We began with a question and moved through gravity, through time, through the patient work of the universe. If this experience has brought you calm, if you have found peace in understanding how the moon came to show us always the same face, I would deeply appreciate your like and your subscription to Relaxing Science. Let me know in the comments, what time is it where you are now? And as you look up at the moon tonight, think about the billions of years it took to become the steady companion you see. Think about the patience of gravity. Think about how all things in time find their rhythm. Until next time, may you rest as peacefully as the moon rests in its synchronized dance with Earth.